This series is part of Tyler's Strength as a nationally ranked art and architecture school with an emphasis on interdisciplinary practice and research. The Wagman series realizes this by inviting artists and lecturers with diverse backgrounds, experiences, expertise, and practices, from traditional to innovative to experimental, to speak to students, offer demonstrations, and stimulate exchanges of new ideas. We will have time at the end of this lecture for questions, and we also will be recording this lecture. So we just ask everyone to please mute yourself. And I will now pass this off to our second year graduate student, Xuan.
Thank you, Jess. Hi, everyone. My name is Zhu Sishuan. You can call me Xuan. I'm a second year MFA in glass at Tyler School of Art. I'm happy to introduce you Percy Eccles II for our today's Zoom. Thank you, Percy, for joining us. Percy Eccles II is passionate about plasma and plasma neon, a process requiring the technical and artistic expression of glass with the alchemical and scientific application of the excited gas and specialized equipment used in neon. He received his BFA at Illinois State University. After graduation in 2016, Eccles worked at Pittsburgh Glass Center as a student technician apprentice. Eccles launched a blog and a podcast called The Taming Lighting in May 2017 to connect with a larger plasma and neon community, build a network, conduct research, and share ideas among artists and makers that use the medium. He was selected as the first recipient of the Ron Demicet Memorial Award for Imagination with Glass from Pittsburgh Glass Center in 2018. Eccles is currently perfecting a mobile plasma lab at Pittsburgh Glass Center to conduct demonstrations for the public and sharing plasma capabilities into different studios at the center. Soon, he will be able to take his portable station into schools as a teaching device that will allow students to realize wider possibilities of crossovers between art and science. Let's welcome Percy. Thank you.
Thank you, Xuan. Hello and welcome to the Laurie Wagman Lecture. My name is Percy Eccles II. As mentioned, I am the creator of the podcast Taming Lightning, which features a series of conversations to help expand our understanding of plasma and neon light, and to further explore the potential of noble gases as an artistic medium by bridging the realms of glass and light art. So I currently live in Pittsburgh, where I'm the emergent neon and plasma technician at the Pittsburgh Glass Center. Again, I'm here researching and developing a space for neon light. But many of the developments have been inspired by the institutions that also have been developing things like this, such as the Urban Glass, Brooklyn Glass, Western Neon School of Art, amongst many sharings and observations of other skilled professions in various fields. I guess you can call what I do or what I am and my curiosity or expressions as being an alchemist, though I often describe to people and use the terms such as artist, alchemist, and educator. In this case, I'm someone who takes what my ideas are and bring them into the physical realm through various mediums and combining of various processes. So I guess I am more of an alchemist than I'm an artist, but they're all the same to me. So today's lecture will focus on key elements from the first 3 chapters of an ongoing collaboration I have with Geeks, that is the Glass Education Exchange, where I'm putting together a 4-part series for an introduction to plasma light sculpture called Intro to Plasma. Now, this is a free-to-public video podcast series with my co-host Ben Orozco that will hopefully create a foundation for which we can dig deeper into the multitude of subjects and topics that make up the processes, practices, and knowledge required for plasma light sculpture. So where do I begin when talking about my pursuit of plasma? To be honest, I got really lucky that I had this opportunity to explore this when I did. Since the chapters align with my journey to present day, it's really best that we start with my origin. So after graduating high school in 2008, I took 2 years at Harlan Community College where I decided I would pursue art in the name of graphic design at Illinois State University. Now, while I wasn't accepted in the graphic design program, I was introduced to furnace glass blowing in 2011. This class was taught by Slade Grove, who was pursuing his MFA under glass by the department head, John Miller. Sometimes I'm asked why I chose glass. Glass just piqued my interest, my curiosity, and gave me something which I had no previous reference for. In that case, it could be the heat, it could be the physicality, but I think most importantly was the community. And with that community, I felt that I could belong to something that would help and that I could help develop and bring new ideas into fruition. In 2013, I was accepted in the Bachelor's of Fine Arts program at ISU, which is a selective program oriented towards advanced professional study in studio arts, consisting of faculty mentors, additional classes, independent study or special projects, and concluded with a solo exhibition. Now, my studies weren't entirely focused in glass. I spent time working in woods, metals, casting, jewelry, expanded media, 3D modeling, animation, 3D printing, all these different things, just to supplement what I had little understanding of in glass. The school pretty much, I think all education emphasizes mixed media and exploring a lot of different things to really find where your skills could be enhanced at. And maybe that's just part of where I take in this whole idea of being an alchemist. But it had a lot to do with the quality of producing light, something that I was always fascinated in. And it has to do with how light can be, focused through refraction or focusing a light through transparent or translucent materials, surfaces, and lenses. The use of LEDs and the idea of interaction and application of motion in light. And the images I have here are examples of works that I applied for that review with. Um, Many of them using LED, but the idea between the two sculptures left and right was to be able to apply motion to a still object or sculpture, and then using this as a way to enhance um, the interaction with people or the viewer to their body and the reaction to the light and the spinning components. So starting in 2014, I took a summer workshop called Interactive Light taught by Patrick Hollentine at the Pilchuck Glass School, which began my introduction to plasma. This is a very introductory class that provided me with the bare bones basics of form and structure, electrode attachment, filling procedure, and a list of resources to buy parts to build a manifold, and most importantly, a mentor and friend, where I was encouraged to give this a shot and a big reason for where the podcast began later on. I guess where plasma sculpture can be defined is as a practice of creating some dynamic lighting display with a glass vessel that are also interactive by nature of proximity of touch. Think plasma globes or discs seen at Spencer's gift store, or maybe now available at Walmart or Target. And it's its interactive nature that drew me to plasma. And ultimately, I was definitely bitten by the plasma bug and driven to make this part of my BFA thesis. After that class, I wanted to do plasma, and I was very fortunate to run into people that can help me make that happen. The first thing I did out of pure naivete or perhaps a bit of ignorance was to call up a few local neon shops. And the one that answered was Supersign, a family-owned neon shop. The son and neon bender Brad humored my request. But when he saw that it had a single electrode, where neon is known to have two for positive and negative, he was doubtful that this could work. Mind you, I had very little working knowledge, but I came prepared with the proper tools to both power and process the piece. After a quick phone call with Patrick Hollentine, he encouraged me to give it a shot. And while we didn't do much with any other gases other than neon and argon, it was a start. And it was exciting to see someone else become just as excited as I was about the possibilities of this process. Eventually, our schedules would no longer match up, and Brad at Super Science had many installs or repairs to do, or my schedule at school had become a barrier. It was then that I remembered that one of the students in Pat's class lived in Chicago, Ash Williamson, and you can hear about his story in episode number 2 of the Taming Lightning podcast. I had gone to his place, spent the night, we pumped neon and plasma all night, and I had my pieces ready for my exhibition. I guess one lesson you could take as an undergrad or anyone pursuing art, try not to do things last minute, because I did this the night before my show was supposed to be ready to open up. So I'm going to shift towards something a little bit more personal. I think this is something that can help a lot of different people, especially today, and kind of figure out where to find their drives to get through some dark times. So like many who have, are, or will experience when it comes to an academic career or similar signals of adulthood, and its pressures is a sense of looming darkness. College has been something akin to a rite of passage, and among my siblings, a first generation of college graduates. These pressures extract from you waves of doubt and diminishing hope. I didn't feel like I would be able to I didn't feel like there was any opportunities post-graduation. I didn't believe that I could be an artist. Anxiety over valuable work, self-sufficiency, or being independent, self-imposed pressures to make unique work, and increasing hospitalization and the worsening health of my dad all were part of a depression that I kept to my shadow and expressed outwardly as ambition and hard work. A shadow, should I step away from the light, would become a void and consume me. It wasn't just a desire to make light, I needed to make light. So while pursuing my BFA at Illinois State University, I wanted to make something that was truly unique to the program. And that became Plasma despite all the challenges, failures, and many suggestions for program mentors and classmates to discard such a challenging medium. Perseverance, dedication, or obsession, it was perhaps simply the undying thought that if this was going to be the only time I could do this, and if the future was going to be as dark as I perceived, that I wanted to give everything I have to make this happen no matter what. Now, to the completion of my degree, I had exhibited something that was first of its kind, probably to both graduate and undergraduate in solo exhibitions at ISU. So I guess maybe we should talk about then my BFA exhibition. Well, it was born from the idea known as catabasis, essentially a hero's journey to the underworld, in which they face many challenges in order to return to the world with some kind of knowledge or boon. I used this as a way to channel my depression and had created narratives and characters based on mythical storytelling or somatic symbolism, a term I developed to describe using the body as a reference to explore concepts or ideas. Personally, the works were highly unrefined and lacked appropriate study. After all, I did end up pulling this off in the last year of my program. Even still, the overall reception of my exhibition was positive, even though the overall quality was being greater than the few sculptures that were exhibited, titled Catabasis Immortal Imperfection. To paint a picture of this exhibition, and I apologize for not having a lot of great images of this. The space had glossy black walls and a floor of reflective black tile, with the only illumination being black lit bulbs and a triangle formation of plasma sculptures. As you enter the space, you enter void. Voices and scuffling are heard, but your attention is on the illuminated sculpture seeming to float in space. Depending on where you enter, you either face a floating set of lungs made of masks or faces with plasma illuminated bronchioles with light refracted through the spine with a series of 3 protruding tongues. Or a head floating above a limbless torso comprised of plasma illuminated spinal cords surrounded by illuminated wire contouring the body. Once you pass this threshold, a triangle is formed by a third sculpture, a bodiless figure composed of a mask draped in translucent shroud that refracts the visible pulse of a heart illuminated by plasma light. After a few moments, your eyes adjust and people appear before you, and you notice a fourth sculpture reflected by the light in the corner of your eye, a festering growth of reflective bulges restrained by rusted chain. Now, to my inexperience, the best single sculpture from the exhibition in both execution and documentation was the Telltale Truth, the set of lungs. The Telltale Truth was conceived by the idea of death and family, where I learned that the passing of my grandmother on my dad's side, Grandma Josephine, that she was known as our family orator, having been able to tell a story of each person in our family tree. While I wasn't close to Grandma Joe, I felt like I should have been. You could say that the precursor to what I do now, which is with the podcast, has to do with the idea of wanting to share stories. But it did motivate me to look at my ancestry a bit, drawing on African roots from Cameroon, but essentially I was inspired by African masks, their meaning, power, and symbolism. Putting it all together was simple, though the execution brought challenges in multi-process assembly. Cast glass, blown glass, hot sculpted glass. The masks represented lungs that joined 2 families. You have roots as bronchi or bronchial trees that connect you to your origin. The spine as a trachea represents the trunk, a funnel for your experiences, and the tongues are fruits of the experiences that interact with the world. Now, since there isn't a great segue to the next topic, perhaps a brief intermission of honesty is warranted here. That is to say that the way I handled my anxiety and depression was not in any way healthy. That I take too long to seek help. that in spite it impacting my resilience today, I empower you or anyone you know who may be experiencing mental health problems to please do your best to seek medical help and support for recovery. 2016, I moved to Pittsburgh for a year-long studio technician apprenticeship at the Pittsburgh Glass Center. At this program, I think it was one of the best choices I made of the options I had available to me. They provide you with housing in a nearby neighborhood with support of a community, a stipend for groceries and materials, and plenty of studio time when off the clock. Additionally, I think it's great to have the free summer classes you could take during your apprenticeship, but also you learned about the processes, you learned about the tools, you were the background or the backbone to the facility's function. Everything ran smoothly because of your insight, because of your help, and you wanted to help and be there with people. Some other programs kind of miss that. They treat you more as an intern. And as an intern, you're probably mostly hands off. You had to find other jobs or housing just to do the internship. I think that's wrong, and that's what I appreciate what Pittsburgh Glass Center has been able to provide for many other technician apprentices and support those apprentices post their service. Now, in July 2016, I happened to be there when a donation of neon equipment was donated. Not knowing what to do and never really handling this equipment, I called Pat. He directed me to document and inventory all items of the donation, read through all the included papers and manuals. And after that, he encouraged me to write a proposal to assemble, research, and develop a system for neon, but mostly plasma at the Pittsburgh Glass Center. Now, at the same time that I'm doing this stuff, that was when I started getting an idea for Taming Lightning. Because it was kind of difficult to understand what was going on in terms of this equipment, how to assemble it, what needed, I spent that same time talking to different artists, getting their story, and then kind of building that community, building a network so that people can look to. By September 16th, I submitted my detailed proposal for a compact and mobile cart, research for versatile use in hot shop, flame shop, and kiln shop in future classes, examples of class structures for guided experiences, including 2-day workshops, hands-on and lectures, gas resources, etc. By December 30th, 2016, I had the cart assembled and fitted with neon and argon gases. Within that first summer, I started some of my first collaborations with plasma. First up was Robert Mickelson, who had experience with plasma, having worked with Wayne Stratman. And then by the time we got to Chris Ahalt, I had to have enough workable knowledge to successfully make the piece and get the ideas across so that we can have a successful collaboration. Unfortunately, it did take a little bit longer to finish this because we had not conceived of the ideas of how to mount or display the work like we did with Robert Mickelson. Again, this is highlighting the value of the Pittsburgh Glass Center as a nexus for art and glass. I'm going to kind of skip forward a little bit on this. There's definitely a lot more I can really talk about on my backstory, but by 2018, I received the Ron Desmond Award, Memorial Award for Imagination in Glass, allowed me to pry and make some new works, but as well as upgrade that system, adding krypton gas and adding windows and kind of making this thing a little bit more functional and less intimidating. Again, 2019, Advancing Black Arts in Pittsburgh grant in residency hosted by the Pittsburgh Glass Center, but funded by the Pittsburgh Foundation and the Heinz Endowments, allowed me to make a complete rehaul. I wanted to make something that was not intimidating, could foster curiosity and interest in plasma, but also making it very viewable and comfortable and fully self-contained. That includes an independent gas torch and all those type of things. So the second chapter of this has to do with taking shape. And so the first thing I bring up is the elements of plasma diagram that I created to provide a scope of information involved in this process. You'll notice that some areas are more defined in the overlaps, and that shows that different categories cannot be neatly studied in isolation, that a healthy curiosity, respect, and understanding is required for the growth in this field. Whenever I talk about this diagram, I start with vessel crafting, which we'll get to in just a moment. So vessel crafting is a means of facilities, education, materials, and techniques related to glassmaking, containing the topics of vessel crafting, a vessel shape, structure, size, and choice of electrode, along with its electrode placement. Alchemy, the means in which pieces can be processed and filled for plasma, containing topics such as cleaning, adding phosphors, glass color, filling technique, and gas mixtures and recipes. In technology, the facilities and means to learn, educate, and practice processing, filling, and finishing plasma sculptures, containing the topics such as the vacuum manifold, gas transfer system, gauges, equipment maintenance and use, transformers for plasma, which includes considerations for resolving your sculptures aesthetically and safely. Now, to rein that in, let's talk about the anatomy of plasma sculpture. In our 4-part series, we talked about that in 4 parts. You had the glass envelope, the gas mixture, electrode, and transformer. And perhaps a 5th one could be the build or assembly. But as an artist, as a sculptor, that is a given in your practice. You should, at least I hope, have an idea of the entire finished piece so that you can make all your adjustments with the least amount of change and extra research or efforts. So let's break it down. So the glass envelope is a closed and sealable form. The gas mixture, which includes the combination of noble gases, be it helium, neon, argon, krypton, and xenon, and or other gases such as oxygen or nitrogen. The electrode, which is a conductor that carries the electrical charge from outside the glass to illuminate the gas mixture. And the transformer, which supplies high voltage and high frequency electricity to the electrode. So, vessel crafting. Why should we talk about vessel crafting first? Well, it contains the most variables that influence the behaviors or light display produced by the plasma. Regardless of whether you come from a glass or technology or scientific background, vessel crafting is highly underestimated when it comes to navigating plasma. So, how do you define what the difference between a glass vessel or envelope in the context of plasma? Well, I use both glass vessel and envelope interchangeably within the context because it's a vacuum sealable glass form that will contain gases. And this vessel must also be structurally designed to support atmospheric pressure. So structure and atmospheric pressure. Structure is to support the object or a load. And in this case, load is an atmospheric pressure. Pressure is the force that is created when atoms and molecules or particles strike the walls of their container. And then when we talk about vacuum, we are comparing the pressure inside the vessel to that which is outside, which is atmospheric pressure, which is the pressure exerted by the weight of the atmosphere, the air, which at sea level is approximately 14.7 pounds per square inch. So on every square inch of your surface, you are about 15 pounds of pressure applied to that. So you need to make your structure, something like a submarine is a great example of a form and structure built to resist high pressure, the weight and pressure exerted by the water on the submarine. So why is that so important? Well, the first thing is to be able to prevent and mitigate the risk of implosion. An instance of something collapsing violently inward, the rush of air filling a vacuum can carry enough force to be considered an explosion as fragments of the vessel pass each other. But don't worry, there are 2 instances where an implosion can occur. Number 1, during the pump down or evacuation of your vessel prior to filling, which is preventable by proper structural design, execution, and inspection. And 2, by being broken by impact or drop, post-filling and possibly in the finishing process of your vessel. And this can be mitigated by adjusting the fill pressure relative to the scale or volume of your vessel, which you can see and watch chapter 3 for more information on. So we need to look at some guidelines for vessel structure. This is a place that many of us will be sticking in as we start to dip our toes into the process of exploring and learning about plasma, especially those who come from a glass background. Number 1, eye protection. I don't care who you are, where you work, safety should always come first. And I'll be the first to quadruple down on wearing eye protection, no excuses. There's an example I presented on the blog from Bruce Suba, where he talked about someone who was saved by the skin of their contact lens during an explosive pressure from a high pressure tube in a scientific environment. This person, young, did not wear eye protection and ended up making a mistake that caused that explosion. They were done for the rest of the day, and I hope that they learned afterwards to constantly wear eye protection. Next, to ensure that you have proper seals and enclosures and welds. Tiny holes or gaps in your vessel, aside from the electrode or tubulation, will lead to weak vacuum or unsealable or unpumpable piece. And this will be the most common issue that we'll be troubleshooting with making a plasma vessel. And here I have an example of a job I did for the Glass Axis in refabricating a piece for their vacuum manifold, where you can see a tiny little leak that is spotted by pulling the vessel under vacuum and checking with a leak checker. You want to make sure you have adequate wall thickness. You don't want any flex in your glass. You don't want to overstretch the amount of material that you have. Just like if you first time blowing glass, you took a single gather, you blew it about golf ball size, it's fine. Gets as big as a basketball, it's super thin. You don't want to overuse or overstretch your material. And you also want to note that the form and shape of your glass can alter the integrity of your thickness. Think about how jack lines are designed to create a breaking point. Or another example, Hershey bars or Kit Kat bars as an example. Round is good. It's no coincidence that the light bulb is shaped the way it is. A circle is a mirror of an arch, a tube an extruded circle, and by rotation a circle becomes a sphere capable of distributing force evenly. In this case, we have to watch out for the concave and convex surfaces. If it is too shallow, it ends up being too flat. So I'm using my collaboration with Darius Sandberg as an example of a work with a lot of convex and concave variations in the surface. Which leads us to our next point. Avoid large flat surfaces. The surface will not equally distribute the weight of the atmosphere, and the larger the surface, the more likely it will fail. While all the edges are supported, the center bears all the weight. But there are some exceptions, and if you dare and if you must use some type of flat surface, proceed with caution. And sometimes that can be mitigated or even strengthened through thickness. And we do have a ratio from Ed Kirshner, the 1 to 20 thickness to length rule that allows you to safely construct your pieces. Here we have a cylinder, 5-inch diameter, and the flat surfaces are reinforced by having them a little bit greater than a 1/4-inch thickness, fabricated by Bernd Weinmeier, who they often work together on pieces. So the Scientific Glass Bar is capable of doing that. But the effects here are not indicative of its form. There are some other special things he does to make this happen. But definitely love his work, and is a good example of that. I myself have also broken this rule by making some geometric forms, but there are some other workarounds besides thickness. Geometry can be a huge factor in being able to strengthen your form. If you guys are familiar with the old video games or whatnot, you have the very blocky polygon, Legend of Zelda, 64 figures. The more surfaces you have, the more closer it is to becoming a smoother surface. That kind of how high-res 3D works today. So you can actually reinforce it by reducing the surface size, the flat surface size, but reinforcing with ridges. You also find that also in like canned goods and other reinforced objects that you see into everyday use, how some sort of surface deformation can strengthen the structure overall. You want to also maintain the surface of your glass by checking for imperfections, scratches, or foreign inclusions. You want to do this because scratches, chipping, imperfections create structural weaknesses. It's like how scoring allows you to break a sheet of glass, rod, or tubing, and often used in controlled braking such as hot popping. Some examples of foreign inclusions include stones, metals, or even cords, which are a string of particulate formed when parts of the glass crucible break down. Big note here is that if it's in your glass and it shouldn't be there, be wary. And here I have a video clip from documenting myself assisting Dr. Jen Figg and Matthew McCormick for a large-scale glass drop and LED installation, in which I'm checking all these individual pieces of glass for cracking, in which we will just throw away and recycle, stones or inclusions, in which we will cut out the inclusion and then recycle the rest of the glass, and then stress, in which we will just simply re-anneal it. In this case, we cannot allow a piece to escape our sight. If we think there's a possibility of a problem existing from observation, we cannot we will become liable for that if that passes our inspection knowingly. So in that case, it's even more important that we are paying attention to that now in the process of creating a vacuum sealable vessel. You also want to watch for stress and compatibility in your vessels. Spend time to properly anneal your glass. Make sure the colors of the glass types are compatible with each other. And note that when you're putting your glass under vacuum, it's the moment of truth. There always seems to be a pressure and limit on your time, but do note that your impatience will be punished by karma. Sometimes the best thing is to start again. So you can watch Chapter 2, Taking Shape for more, which adds on aesthetic considerations, geometry, surface qualities, examples, electrodes and how to attach them, and considerations for placement, as well as practice exercises. And now the final part of the lecture, Chapter 3, which is the most recently released chapter of the Intro to Plasma series, which we'll talk about is collaboration. Though this chapter is combining both alchemy and technology from the elements of plasma, which it's really hard to separate because of how integrated they are, I want to emphasize the importance of collaboration in this final part. So what do I mean by collaboration? In plasma, your collaborators will be institutions or individuals that fill your pieces for you. Unlike neon or commissions in glass, there isn't a standard which can be applied yet to plasma. Due to the exploratory or experimental nature of plasma, due to countless variables of the vessel, such as form, surface, size, constrictions, cavities, etc., they all affect how the gases will behave in the mixture. Meaning that you can have identical forms, you can have not identical forms, you can have identical volumes of different shape with identical filling pressures and mixtures and get a different effect. That's kind of why it's a bigger issue here, why we can't call it a fabrication or commission in this case, that it has to be a collaboration. So then why emphasize collaboration? Well, the equipment can be hard to understand and find. It takes commitment and luck to pursue. It can be expensive to start and frustrating until it is dialed in equipment-wise. For me, there was no better option than to pursue this in this fashion, and I'm curious and I like to learn. So my time will be split between development, building, and establishing procedures and integrations with my institution, on top of pursuing my own personal works and collaboration through ideas and execution. But if you work with a collaborator, you can explore and test the waters. You can focus entirely on making the art and support the individuals and developing institutions in this field. So then what are some examples of collaborators? Well, I have a few from Chapter 3. First up is Zach Willis from Glass, Raleigh, North Carolina. He was introduced in episode number 17 during the Glass inaugural Plasma Parlay, and he has started doing work with this just recently. And so he's open to be able to help people fill pieces. He's very comfortable with flame working glass. He's an excellent scientific glass blower, and he does a lot of work with neon as well. So he understands both the art scientific processes here. You may also go to Urban Glass. Emily Craddock is one of the technicians there. You may also work with other staff technicians there as well. They have a listing of prices for low and high pressure fills, but you'll have to see Chapter 3 to understand what they mean by that. But then you can also listen about her on the Mondo Neon podcast, kind of a brother podcast in terms of neon and plasma. And then we have Bruce Suba, see episode 25, who's out in Scotts Valley, California. Neon, plasma, scientific glass, this is the guy for you. He may not be comfortable with perhaps fixing pieces for you, but he's willing to teach you and help you learn how to do things yourself. So that's a great part of him being part of this list of collaborators. And so far, I've confirmed that we have 3 individuals who are offering services. It doesn't mean that there won't be more. It doesn't mean that that's all there is, but it does show you where this field stands currently. I'll keep looking for more people, but that's why my next port is very important because of the scarcity. So how do you start a successful collaboration? Oops. Oh boy, almost lost power. So the first thing to do is do your homework. Watch the Intro to Plasma series, join the online communities such as the Plasma Art Alliance and the Neon and Plasma for Beginners group on Facebook, and to ask questions. Manage your expectations. Try to have a clear goal in mind of what you want to make and explore. Ask questions of your collaborator and ask your question of your collaborator. Ask for what services they provide, the costs and expectations they have from you. Also, one thing that we didn't ask is ask if you can watch the filling process. We have technology, guys. See if you can video chat. And then stay open to the possibilities and trust your collaborator will do their best. Sometimes the things that you want to have happen aren't possible with the pieces you create, but trust that your collaborators will then seek your best interests in the final product. Leaks and failures will happen. Do not expect the leaks will be fixed for you. Some may fix leaks on the electrode connections or on the borosilicate plasma vessels. This will depend on their comfort and skill level. Otherwise, they will simply point out the leaks for you. Batch plasma vessels whenever possible. Don't cut corners. Provide yourself with more opportunities for success. Remember, multiple vessels equals more chances for successful fills. And send your transformer you're planning to use with the piece. Having multiple transformers will help cover the range of effects and sizes, and your collaborator will tune your piece to the transformer itself. And then you can check out and watch Chapter 3, It's Lit, Chemistry of Collaboration, to see things about what is plasma, plasma versus neon, gases and effects, phosphors and glass colors, overview on the filling process, and a list of collaborators and expectations, and more. Which you can find on geeks.glass-resources. So now that we have kind of the bulk of my talk done here, which is really introducing the Intro to Plasma series, breaking out some key points to get you started to think about plasma and understand the scope of the things that's involved in this process, we can take a step back and take a look at the work that I produced. So in 2019, as part of the Ron Desmond Award, I created and worked on pieces called Onus. So these two pieces here are the same piece. This is me applying two different principles. One is power through the electrode, which is the one on the right, in which you can see it has one effect. And then on the left, I have the piece powered through the chain, acting as a capacitive electrode, meaning the electricity and high voltage travels through the chain and extends itself through a field created by the chain onto the glass, giving a completely different effect. This is kind of inspired by the pieces I've started to produce early on for my BFA, and I'm trying to bring those works back into the space with plasma. I do run into trouble with trying to figure out how to assemble them and make them so that they are also safe to touch or interact with, or in case there is accidental interaction. But that still requires much more play and research to do, but I do enjoy the kind of unpredictability of the form that's created this way. And I have a collaboration I've done with Daria Sandberg, who's a local artist that I started doing work with. She's known for using glass in various amounts, whether it's recycled glass, working with cast glass, and using mixed media, painting, drawing, all types of things. And I remember seeing that one of her imagery is clouds and ladders. And I saw in a sketchbook an idea for a ladder inside of a cloud, in which we began doing that as well. When I felt comfortable enough to make forms, we started trying to figure out ways to get these ladders inside of the cloud and see what happens when they are filled with plasma illuminated. What's happening here is that you have an arc drawing from the electrode pointing down towards this metal ladder that is then acting as a satellite or secondary electrode in which the arcs are dancing off of that ladder itself, which is really cool. And I want to make more of these. So whenever I can give myself time again, I will definitely go ahead and make sure I put in the time to, make more of these, because they're really exciting to figure out and watch. And that's currently in the Light and Transmission exhibition show that's up right now at the Pittsburgh Glass Center. You can always, if you can't travel, then you can always check out the virtual exhibition online on our Flickr page. And then bringing back the Plasma Mousse trophy collaboration with Chris Ahalt, who made the glass and I filled it. So this was filled back in 2017. And the reason for putting this piece back in and talking about it is to emphasize where we kind of went wrong on this. So even though it was filled back in 2017 and could essentially run, we had not considered how to finish the piece off. You see, we did not design the work to be assembled and mounted. We had no idea how we wanted to display it, unlike the piece, the Illuminate Lady with Robert Mickelson. So it took me 3 years to figure it out. I had to go through a process of observing other people's solutions. Harriet Swartrock has been a big person in this aspect. She used a combination of things to adhere the back of her hearts with some kind of mounting device. I had to explore capacitive coupling, which is the ability to indirectly transfer high frequency electricity and high voltage electricity through the glass. And it ended up becoming layers of different things. And we talk about this a little bit more in chapter 3. So it might go over your head a little bit, but what I had to do was sandblast the back of the head and use a carbon paint, which is conductive. The tooth, I needed a tooth to paint that on there. Then I had to attach the wire to the back of that head where it dissipated that energy. And I used a conductive silver epoxy. And because I needed to protect that area and seal that environment, I had to use a moldable silicone. Then I eventually bought a 3D printer and was playing around with that, created a plastic mounting element with nylon screws so it wouldn't arc through and damage anything, and then used like PC11 epoxy and stuck together. Eventually completing this with um, a 3D printed mount, which was beautifully documented by Nathan Chalice from Porter Loves Creative. So I'm happy that he got the work. It took a long time. I know his daughter was asking about it for quite a long time. But yeah, that's the end of my presentation.
Well, thank you so much, Percy. That was wonderful. I think we still have about 10 to 15 minutes where we can open up for some questions. And so I'll ask Schwan to help me navigate questions that people have. And I can start it off with just saying how inspiring it was to hear you speak about challenges you overcame during your undergrad. And since we have so many undergrad students here, I thought if you could offer some specific strategies that got you through some of those challenges.
You'll probably hear this from a lot of different people, all types of influencers or whatnot, but it is truly having mindset, developing a mindset, but you can only maintain that mindset only so far. So it requires you building and strengthening the community, having a few close people to keep you accountable, people that would help you push you in the right direction. If you are having any type of difficulties, mentally or otherwise, hopefully you have someone there to help you push into getting that help. That's going to be better for you than trying to handle it all yourself. That's 100%. Because like after doing that exhibition, I broke down. There was nothing it could have gone real bad. So it's really important that people understand that you may think that you have to do it yourself. You don't. The world isn't built like that. Humans are built with communities for a reason. So take advantage and support the people around you and accept that support. Find someone that's going to help you with that. Find people that's going to support you.
Mm-hmm. Well, and speaking of communities, you working with and at Pittsburgh Glass Center, could you talk a little bit about the Pittsburgh community and how you got involved, how you got started, a little bit there?
Yeah, I mean, it started from day one, really, from the second I got into the apprenticeship. Because what you're going to find if you go to Pittsburgh is a lot of people that are there now are people that have been there at some point before. Something about really people wanting to support each other is part of the power of Pittsburgh. Like, for example, we have classes that ran, right? You have classes running, and they're not just taught by staff. They're taught by the local renter community who are trained to handle working with staff, working with the audience, working with the community through these workshops. So it's community power to begin with. And those people who are teaching workshops as renters or those who are skilled or trained or interested to assist in the process with the glass are supported and compensated for that. So that's number one. You're always surrounded by people who want to help each other, who want to be there. And that's part of what began that. So after that apprenticeship, I had got into a residency, which was something that they're always connecting people with all types of stuff, commissions, residencies, and Pittsburgh Glass Centers offered it for past technicians and current technicians. And so I applied for that, and then they helped curb the cost of the studio cost. And the people that's involved in that, the Brewhouse Association, which is part of the residency that I had done at that time, it just opens up more. You kind of just can't help but to be part of it in some way.
That's great. And if anyone would like to ask any questions, feel free to either write stack in the chat or unmute. I'm scrolling through.
Hi, Percy. Thank
I
you.
had a question. Oh, go ahead, Steven.
After you, Cooper.
I was just thinking about display for this kind of work. It seems like a lot of times it requires like pure pitch black rooms. Is that something that like you just take as a given, or do you like consider like the like ambient lighting when you're designing your work?
So that's a really good question. So when it comes to lighting regarding these works, plasma will never be as bright as neon. And that's something that you have to kind of factor into how you display it. So pitch black is like the ideal, but it doesn't have to be pitch black. You know how you could kind of imagine like your apartment or dorm kitchen, and you have like the window, but you have the lights off and the shades pulled over. Just visible walking light, but not like full on all the lights on your house light. That can work, and there's some strategies you could employ there, such as shadow boxes to kind of help contain and shield it from additional lighting in the area. I think the thing with the light and transmission exhibition, it's kind of helped me see and organize that problem, because we had a lot of neon pieces there as well. Some pieces are very bright, like Wayne Strabman's pieces are very bright by whatever magic he employs, but it's very different from some of the very glowy and well kind of misted like filling pieces. So we had to push those further back. But there's a way to balance it where you get both, visibility to walk through the space, but also you get to view the piece in its best possible environment for like a gallery exhibition space. I just went to the extreme for my BFA because I had that control.
Stephen, did you have a question?
Yeah, thank you, Percy, for your talk. You put a lot of emphasis on opportunity, connections, collaborators, and I was just wondering, how you evaluate those, like, and what's the best connection to make?
Can you define it a bit more? What do you mean by the best connection?
Like, how do you determine like what's the best opportunity? What's your evaluation process for that?
Well, first of all, you can't always predict an opportunity until you take it. So if you're saying in regards to a collaboration, that's kind of why we labeled it chemistry of collaboration for that chapter, because you're gonna have to feel out that relationship. It's not kind of like how you can't always be everyone's best friend, but what you're looking for is someone who is willing to, at least what I'll give you from my perspective as someone who's collaborated with people and provided the filling process, is I want to see growth on both sides. So my thing is synergy. If I'm producing a problem and working together, then I should be able to feel like I can raise to the next level in this instance, and that other person should be able to feel like they've gained an understanding in this instance. So we're both moving up. It's a vague answer because there isn't like a true criteria, but there has to be respect. There has to be willing to understand. You have to see that the prices work for you and that you're willing to communicate very well in this process. communication could be 100% because, right now you may not have people that are going to let you come into their studio spaces due to the pandemic, but we have video that we can start to creep into and make things happen. So looking for people that you can gel with and that you can help each other work through this process. It shouldn't be totally one-sided in any capacity. I hope
Thank
that
you.
answers that for you.
No, yeah, totally. Thank you so much for your thoughts.
Yeah, you're welcome. Thank you, Stephen.
And Percy, we have a couple of questions in the chat. One from Emily saying, I'm wondering what has been the most surprising to you about working in plasma and the plasma community?
Well, most surprising is how I'm able to constantly connect with people. Like, if you listen to the podcast and you listen to like anyone talking about neon and even things about plasma, you'll find that it's very hard for people to like find the support or even like someone willing to work with them to learn the practice. But what surprises me in the community is now that like I continue to run into another person, they know this other person, and it continues to like open up. So like instead of running into doors, I run into like welcoming spaces, and I'm running into people who are now connecting with other people that I've talked to previously only because I talked to them or talked about them. So seeing how things are constantly opening up and not shutting down, that's the big surprise for me in terms of the community. But if you're talking about plasma by itself, how the tiniest thing can change things. If I go back, can I go back on the screen? There we go. To these pieces here, they're relatively the same cloud shape, right? And at one point I had both of them filled with neon. And for some reason, this one lit up red and this one didn't light up, and they were connected at the same time. Those kind of slight differences based on where they are in the system, even if they're hooked up at the same time, doesn't mean they both evacuated the same way. And so I'm constantly learning and unlearning things all the time.
Another question is, what's the value need for scientific and electrical engineering to build intentionally in the development of a piece?
Can you read that again for me?
Yeah, what's the value need for scientific and electrical engineering to build intentionally in the development of a piece?
Oh, super duper high, like higher than the sky, to the edge of the universe. That is the value and the need for that. Because neon has been around for over 100 and so years, it's pretty standard, and the equipment and transformers needed today are smaller and better than before, and they're standardized. Here, if you check out chapter 3, I talked about how like I was able to be sponsored by one of two places that produce transformers for plasma. You'll find if you look on Instagram or online that a lot of people are making their own transformers. There isn't an industry standard yet for that, and it does mean that if those guys stop making it, we're not going to have the quality that we do have now. It can always improve, and it needs to improve. Honestly, it needs to be a standard in some ways that we can have high quality components for our transformers, and that's a big thing that we're talking about in the Plasma Art Alliance on the committee.
And we have a technical question. Do you know the average lifespan of a plasma piece and how that compares to a neon unit?
So I would have to say here, shoot, that's a hard one because neon pieces have been known to last for like 70 plus years. A properly done piece, say Larry Albright from the 50s, has lasted quite a long time. So a little bit over 50 years. You have Mundy Hepburn. He's made a piece that's been lit up every day in the New Britain Museum in Connecticut, and that is been on for 20 plus years. So done properly, it could have similar lifespan as neon. And that's kind of like the hard part there, because what is done properly properly. A lot of people have different approaches, and there are kind of workarounds, but there is indeed a middle path to what needs to happen and what needs to be done for it to be clean and proper. But in the end, it's a little bit uncertain how long a piece will last.
We have time for maybe one more question.
Mhm.
I got a message of another technical question. How do you keep larger pieces hot enough to not crack in front of a torch?
I'm not sure I understand. Is that person still there to ask questions and details of?
So Abby, I think.
So I'm curious of what that means by, is that like, what type of glass are you using? And
Yeah, Abby. Oh,
I didn't. If she
Yeah.
was saying so, I didn't hear it too clearly. So
Oh, yeah.
I'll try to answer the best I can. So how do you keep big pieces from cracking at the torch? If you're doing this with soft glass,
Mhm.
you it kind of depends, right? So technically, you could apply the electrode directly while it's still hot, just off the punny or knocked off on the knockoff table, and you're just going to have to be just present and 100% on it. Or if you're doing this post kneeling, where you've created a small thin tube or tubulation off the end, and you're attaching your electrode or things like that, then you can set yourself properly and comfortably to slowly take that time to heat up the tubulation to add your electrode, but
Mhm.
then you still have to re-anneal it. So I think understanding the glass material and the limits based on thickness, timing, setup, shape, and form will be your best factors in keeping it from cracking at the torch.
Mhm. Well, and Percy, you have such a depth of knowledge and information on your website.
Mhm,
And so I posted that link into the chat.
mhm.
So I would suggest for people to just really take a look. There's so much there. You definitely keep yourself really busy. Wearing
Yeah,
a
yes,
lot of
indeed.
wearing a lot of different hats. And so I think we've hit our time and could spend another many hours with you. So
Right.
thank you so much for joining us today and for answering questions and sharing all of this with us.
Yeah, it was
So
awesome.
yeah, it was great. Thank you.